The postseason test in Abu Dhabi offered the clearest indication yet of how aggressively Ferrari is shifting its technical direction for 2026, and it quickly became evident why Lewis Hamilton described the experience as eye-opening. What should have been a standard tire evaluation evolved into a controlled trial of next-generation concepts, with the SF25 Mule running ultra-low downforce wings, modified load distribution, and an early iteration of the active front wing system that will play a central role under the new regulations. For Hamilton, this was his first chance to feel, rather than theorize, how Ferrari intends to tackle the aerodynamic instability that defined much of the 2025 season. The technical differences stood out immediately. Ferrari's active aero actuator appeared more refined and compact than the version Mercedes tested on the same day, hinting at a more advanced packaging philosophy. Hamilton also evaluated the prototype steering wheel that simplifies control logic and aligns more closely with the ergonomics he used during his most successful years. Combined with the altered aerodynamic platform, these tests allowed him to analyze how the mule responds through the medium-speed phases that have historically exposed Ferrari's weaknesses. What the session ultimately revealed is that Ferrari is preparing a structural reset rather than an incremental update. The feedback Hamilton collected on load variation, tire interaction, and aerostate transitions gives him direct insight into a concept fundamentally different from the SF25. Ferrari's testing program in Abu Dhabi offered one of the most informative glimpses yet into how the team intends to adapt to the regulatory changes coming in 2026. Rather than treating the day as a conventional tire evaluation, Ferrari used the opportunity to introduce systems and components that reflect the operational demands of the next era. The decision to field a mule car tailored to reduce downforce running underlines the team's intent to gather meaningful forward-looking data rather than simply concluding the season with standard procedures. The reduction in aerodynamic load was deliberate, allowing engineers to assess how the SF25 platform behaves when forced into a performance window much closer to what the 2026 cars will require. This approach is technically valuable because it reveals how predictable or unpredictable the chassis becomes when deprived of the current generation's downforce levels. Medium-speed cornering, an area where Ferrari struggled in 2025, was particularly relevant. Engineers could identify whether instability originates from the aero concept, mechanical platform, or a combination of both. The introduction of an active front wing mechanism provided one of the most significant technical differences compared with previous tests. The actuator system installed on Ferrari's mule car was compact and integrated neatly within the nose structure, enabling control changes to flap angle at speed. This early experimentation will be crucial for understanding how the car transitions between aerodynamic modes, especially given the FIA's upcoming requirement that both front and rear wings must operate together under the X mode and Z mode systems introduced for 2026. Testing the actuator's behavior on track also allowed the team to register how the airflow reattaches when the flap returns to its neutral position. The speed and stability of this transition will influence how aggressively drivers can switch between modes during racing situations. For Ferrari, determining whether the current hydraulic design maintains consistent performance across different speeds and temperature profiles will inform the hardware choices on next year's chassis. Hamilton's contribution to the program extended beyond driving duties. His feedback on the prototype steering wheel, designed with a simplified interface, helped Ferrari refine control placement for future aerodynamic toggles. In 2026, drivers will be responsible for managing aerostate changes far more frequently, making ergonomic optimization essential. Hamilton, with his extensive experience working with complex hybrid systems at Mercedes, offers insights into how these controls should be structured for efficiency and clarity during high-load phases. The mechanical aspect of Ferrari's testing plan was equally significant. The team introduced what they described as a transferable rear-end solution intended to offer preliminary data for the architecture of the 2026 car. It included evaluating how modified suspension elements influence grip, rotation, and energy transfer under reduced aerodynamic support. These observations will be valuable as Ferrari finalizes the suspension geometry for the new chassis, which will need to operate effectively in a downforce environment substantially different from 2025. Ferrari's mileage across the day, 270 laps shared between Leclerc, Hamilton, and Behrman, ensured that engineers collected a wide range of data across different track conditions. The absence of reliability issues meant that the team could focus entirely on correlation work, validating simulation predictions against real-world responses. This is particularly important given that aeroactive simulations require high-accuracy modeling of actuator forces, flap angles, and airflow transitions. One of the advantages for Ferrari was running without the 300 km/h limitation imposed on non-mule cars. This allowed Hamilton and Leclerc to experience how the aerodynamic package behaves at full straight-line speed, where drag reduction becomes a critical variable. Understanding how the car stabilizes or destabilizes under these conditions is essential for calibrating the aero maps required for 2026's active systems. A comparison with Mercedes provided additional context. While both teams tested active aero solutions, the visible differences in actuator placement and design philosophy suggest that Ferrari may be prioritizing packaging efficiency and response uniformity. Whether this translates into on-track performance will only be known as the development cycle progresses, but the early divergence illustrates how teams are interpreting the regulations in distinct ways. The data gathered from tyre behavior was equally relevant. Even though lap times were largely meaningless, Pirelli's prototype compounds will play a central role in defining how teams manage energy, braking, and corner entry in 2026. Ferrari now has a clearer understanding of how these compounds interact with reduced downforce configurations, which will influence mechanical setup and suspension philosophies moving into next season. From a broader strategic perspective, Ferrari's approach in Abu Dhabi reflects a recognition that incremental adjustments to the SF25 concept will not be enough to compete in 2026. The team appears focused on establishing a completely new aerodynamic and mechanical foundation, ensuring that early development aligns with the demands of the new rulebook. This marks a shift from the reactive approach seen during parts of 2025, suggesting a move toward more proactive engineering planning. For Hamilton, the insights gained during the test provide essential context for assessing Ferrari's direction. This was his first opportunity to evaluate how the team is integrating new technologies, restructuring driver interfaces, and addressing long-standing weaknesses. The combination of active aero experimentation, revised steering ergonomics, and updated mechanical components offered him a more comprehensive understanding of Ferrari's readiness for the next regulatory phase. The Abu Dhabi test does not offer conclusions, but it does offer clarity. Ferrari has begun committing resources to a concept fundamentally different from the SF25, and the data generated during this session will guide the early stages of the 2026 car's development. Whether this new direction proves competitive will depend on execution over the coming months, but the intent is now visible, and the foundations appear more robust than at any point during the 2025 campaign. Ferrari's postseason program has shown that the team is treating 2026 not as an adaptation, but as a wholesale reconstruction of its technical approach. Early integration of active aerodynamics, revised mechanical components, and a simplified driver interface indicates that the engineers are already working with a clear interpretation of the new regulations, rather than feeling their way into them. The data gathered in Abu Dhabi will shape the core architecture of the next car, from suspension geometry to actuator response maps, and the absence of reliability issues means Ferrari can move into the next development phase with clean baselines. For 2026, the key performance differentiators will center on how efficiently teams manage aerostate transitions, how predictable the chassis remains with significantly reduced load, and how well energy deployment strategies integrate with the new aerodynamic modes. Ferrari's early testing suggests they are prioritizing control stability, packaging refinement, and ergonomic clarity, all areas where they fell short in 2025. If these insights translate effectively into the new chassis, Ferrari could enter the regulation shift with a platform more aligned to Hamilton's driving methodology than anything produced in recent seasons. The challenge now lies in execution. The conceptual direction is promising, but the gains will only materialize if Ferrari can maintain development speed, ensure correlation between simulation and track data, and continue refining the communication structure that supports the driver at high-intensity moments.